have a look at question 2. So this question just requires the knowledge you have right now. Okay, nothing more. So have a look at it first. So you're pushing the block A such that the blocks move to the right with directive motion between the blocks. So what it means that both A and B are moving at the same speed and the same acceleration. So we don't know whether they have acceleration or not, but at least they are moving at the same acceleration. So it's always good for you to draw the 3-point diagram. So for part A, the mu is 0. I hope you still remember what does mean by the mu. So the mu is a coefficient of friction, is it? So the friction can be written as smaller or equal to mu times the motion. So for part A, so let me get more space first. Okay. So for part A, the maximum value of F. So let's draw the 3-point diagram. Okay, so that 3-point diagram is also for the question B and question C. So F, so that's the weight of the block. The non-motion acting on the block A, because touching the ground, A and B are touching, so there is a non-motion acting between them. There's weight acting on the block B. There is also a non-motion acting on the block B. That's it, is it? So let me copy this photo, copy this diagram. So and then just copy 1 for the part B. Because for part B, you also need to consider the friction. So in part A, there's no friction. So, and you know that they are moving at the same acceleration. If you consider the object A and B as the same object, as one object, and then I think you can write the formula quite easy. That's Fu to Ma, is it? So F is the net force of these two objects. There's no other horizontal forces if you consider A and B as one object, because there's no friction. Right? So this is the first one you can write. The second one is, what does mean by maximum value of F? It seems that they can always move horizontally with the same acceleration, no matter how large the F is. Now, but you need to think, you need to think about the motion by itself or simulate the motion by itself. So if the F is too large, A may slide over B. So that means A may slide upwards relative to B. So at that time, A is not touching the ground. So that means at that time, the N1 equals 0. Because the block A is not touching the ground, then N1 will become 0. Then the block A will start sliding upwards. So in that case, when F is maximum, okay, the N1 equals 0. Then you try to solve it. Okay, angle theta. Okay, so this is angle theta, and then I think this is also angle theta, is it? Yeah, this is angle theta. This is 90 degree minus theta. Yeah. So, and then I decompose the vertical forces because I need to find, we need to set the equation for n1 is 0. So because if n1 is not 0, then you can write it as n sine theta plus n1 equal to mg, is it? But right now n1 is 0, so you can set that n sine theta equal to mg. And then you can make use of this three-bar diagram or this three-bar diagram and consider the horizontal force. So if consider the left-hand side one, you can write it as F minus F. Sorry, this is cosine theta, it's not sine theta. This is N, and then this is theta. You decompose the vertical component, that's N cosine theta. The horizontal component is N sine theta. Then F minus N sine theta is the net force of the object A, so you can write it as MA. Or it's better for you to use this one because the formula will be simpler. So that is F n sine theta equal to MA. And then you're going to solve this one, and this one. Solve these three equations to find the maximum value of F. Although there are three equations, it seems quite complicated, but you know your final target is to find the F. So you're not going to use this equation first because there's an unknown F. So that means you are, and then that means you need to find the A and substitute in this equation. So that means you need to make use of these two equations to solve the A. So very easily, so you just use the first equation divided by second equation. Then you get the tangent theta equal to A over G, is it? So that means A equal to G tangent theta. And then substitute in the first equation. Then you get the maximum value of the F will be 2mg tangent theta. So that's it for the part A. Okay. So the main trick is you need to understand the motion. You need to be able to think to know that A when F exceeds the maximum value, that A will slide over B. 做咩啊? She's smelling. Let me. Then you set up you draw the three-bar diagrams and then solve the horizontal forces, vertical forces, and set up the equations, and then try to solve the equations. And that's it. That's the trick. Okay. The most difficult trick is to know that A is losing contact with the ground. So that means n1 to 0. Okay. That's it. That's it for part A. So let's have a look at for part B. B and C are related to each other, you see. So for part C, for the maximum value found in part B, find the maximum value of F. So we do the part B and part C together. So and in this case, A and B has a friction. And A is also having a friction with the ground. B also have the friction with the ground. Right. So let me draw a three-bar diagram. Now B has a friction with the ground. So let me label as F2. So it's to the left of office, is it? Because B is moving to the right. Now, but in this case, you know what is meant by maximum value of F. So actually it's quite similar to the part A. So when F is maximum, A will lose contact with the ground. So that means there's no motion with the ground. Okay. So I just eliminate M1 in this case. If the A is not touching the ground, then that means there's no friction between A and the ground. But A tends to slide over B, so that means there is a friction between A and B. So A tends to slide upwards, then the friction will become downwards. Okay? And this is the F. Yeah, this is the three-point diagram of the whole object. Okay. Then what you need to do is decompose all the forces along the horizontal and the vertical and try to solve all the equations. In this case, now because you know this one, now this F2 is a kinetic friction because B is moving. So F2 will has a magnitude that is mu times N2. But this F is a static friction. There is no relative motion between A and B. So that means this friction can be smaller or equal to mu N. Okay. Then I try to decompose all the forces along the horizontal and vertical. So for the object A, I just make it simpler to draw a rectangle. So F, mg, so and then this is theta, this is theta. So for friction, the horizontal component will F cosine theta. The vertical component will be downwards F sine theta, is it? Then for the normalization, okay, to the left is the N sine theta. Upwards is N cosine theta. Then for the object B, so mu N2 mg. Okay. And for all the F and N is just opposite to the they have just had the opposite direction because they are adjacent pair. So I just if not, you just do it again by yourself. Okay. Then you write down all the forces for the horizontal and the vertical forces for object A and B. Then for object A, so let's consider vertical force. So that is N cosine theta equal to mg plus F sine theta. Then the horizontal force will be F minus F cosine theta minus N sine theta equal ma. But these two objects are accelerating. Okay. Then for the horizontal force of the object B, so that is N sine theta plus F cosine theta minus mu N2 equal to ma. The vertical force is N cosine theta plus mg equal to N2 plus F. Oh, sorry, this is sine theta. Yeah. So I'll give you 1 minute time to have a look at it to see if you have any question. Feel free. So right, actually you have 5 equations, 1, 2, 3, 4, and then this is the 5th one. Why we need to use this one? Because we need to set up the minimum value of the coefficient of friction, the mu. So normally then you will have an inequality. Okay. If all the equations are equality, you can't write down something like, okay, after you solve the 4 equalities, you can't draw the conclusion that mu is smaller than or equal than something, is it? Then normally, okay, if you are going to solve the maximum value or the minimum value, you have a inequality. And then for the Newton's law of motion, the inequality is always the friction. But actually for the part A, there is also an inequality. So the inequality is it? The inequality for the part A is like this, okay? The n1 is always larger or equal to 0. But when n1 equals 0, okay, then f is maximum. There's also an inequality. So then let's try to solve these equations. Okay, let's try to solve these equations. Although it's really very complicated. I think I've solved it before. So first of all, I would like to use the second one and the third one and then make them together. Okay. So because they all have this this thing, so I can write it as f. So add these two equations together, f minus mu n2 equal to 2ma. So I simplify this equation a bit, and then let's try to have a look at the part. Yeah, it's very difficult because you want to solve the mu, so that means you want to substitute the f and n in these two equations. So that means you're going to try to find f and n as a subject for the equation. And then even for me, I may take a lot of time to solve it. I don't know whether I solve it correctly or not, because I don't know whether my it should be a step that how I solve it, but at least I try to solve it one. It doesn't matter. Okay, just try by error, and then just substitute the first one equation to the second one, to the fourth one, so you can eliminate the n. Is it? So you get m2mg plus f psi theta equal to n2. Is it? Oh, then you solve the n2. Is it? But it seems n2 is quite easy. It's just 2mg. Yeah, because if you consider the whole object, okay, if you consider the A and B as a whole object, there's only one vertical force provided by the ground, that is n2, to support the weight of the object A and B. Okay, so this is a very simple equation that you should be able to solve. So there's 2 mu mg. Okay, I simplify a bit more. Not yet done. Okay, so we are going to solve the fraction and the non-fraction. So what we can do next is just try to maybe make use of the unique thing about it, to solve the question is like this. Okay, you have make use of the combination of 2 and 3, 1 and 4. So that means you only have 1 and 2, 3 and 4 left, and 2 and 4 and 3 and 1. But normally you don't need to do it so many times. But let's say if you try to solve between A and 1 and 2, why I need to solve between 1 and 2? Because there's no or 1 and 3, as you like. Yeah, as you like. It's really as you like. Okay, so let me try to solve between, I don't know which one you like. Maybe 1 and 3 or 1 and 4. So 1 and 3. Okay, 1 and 3. So, and let's say I want to eliminate the n. So what I can do is, so multiple the first equation by psi theta. But always multiple the cosine or psi theta, not divide it by psi or cosine theta, because if you divide it, you make the case much more complicated. And then third equation, and then multiple by cosine theta. Then you have the same thing for the n. I'll just put the mu n2 on the right hand side. Okay. And then you can substitute this one inside here. Okay. Then you get mg sine theta plus f sine square theta plus f cosine square theta equal to ma plus 2 mu mg. Now, cosine square theta plus sine square theta, I think you know that it is equal to 1. So I don't write it here. And then for the n, okay, for the n, then you can make use of the to solve the n, you can substitute the f into the first equation, is it? Then you can solve the n. Although it will be really, really complicated, but at least you can do it. So let me do it faster. F sine theta, is it? So that means 2 mu mg sine theta plus ma sine theta. And then minus mg sine square theta. Now mg minus mg sine square theta, it can be written as mg cosine square theta. You know 1 equal to cosine square theta plus sine square theta. And then divide the whole equation by the cosine theta. And now I substitute the f and n in this inequality. Divide by cosine theta, okay? It will become tangent here. This is also tangent. Of course, we can divide the whole equation by the n, the mass m. And also, let me also divide by the g, divide by m and g. To make the whole equation simpler. Oh, a over g, sorry. Then try to group the same term together. You try to group the same term together. So at least you need to try to group the mu together, is it? So it seems it's really very complicated here. Yeah, it's really very complicated here. But at least for the 9 marks here, half of the marks are given for the 4 equation you have written down. Okay, 4 equation yeah. And then if you want to solve it, and yeah, it is complicated. And also there is also one criteria for the A. So the A is always greater than 0. Then you can try to solve it and then see. Yeah, it's complicated, but At least you can write down the whole the equations. At least you can write down the equation, then that's fine. Okay. Yeah, I know it's complicated, but at least you can write down the equation. So that's it for this question. Okay. Now it's not difficult to write down the 4 equations, but it's difficult to solve this equation. So that's it for this one. And then I'll send it to you now. Just a second. Just a second. Let me. So it take a bit of time to save it to PDF. Oh no, it just finished. So then let's go to the next topic. Okay. I can't find other easy question about the force. Then let's go to another topic. So it's about the inertial force. It's one of the very essential trick that you are going to learn in the Olympic. Hmm? Hmm? So this trick we call the inertial force. Or there are many different names for it. So someone may call it the pseudo force. Pseudo means fake, is it? Pseudo. Do I spell it wrong? Pseudo. Yeah. One of the example is the centrifugal force. I'm not sure if you have heard about this name. One of the example is this one. Or Coriolis force. But we are not going to talk about these two right now. Coriolis force is not in the syllabus. So this is a force that added to the object when considering the non-inertial frame to make such that the Newton's law of motion are still valid in non-inertial frame. I think I gave you some example before. So Newton's law of motion is not valid in non-inertial frame unless we add this force we call the inertial force. So I'm not going to prove this vigorously, but I'll just give you the idea how we going to show it, the formula for the non-inertial force, or for the inertial force. So the formula for the inertial force is very simple. So Fe, the Fe negative ma. So the negative, the A is the acceleration of the non-inertial frame relative to a inertial frame. So most likely you say, let's say the acceleration of the car. Difficult to find the arrow. Here. So this is a vector. Just keep it in mind. So the acceleration A here is the acceleration of the non-inertial frame relative to a inertial frame. So just give you one simple example. So let's consider a car moving at constant acceleration a to the right. So then let me draw the car here. So when the car is accelerating, so you are an observer that sitting in the car. So that means you are at rest relative to the car. And then so let's say there's another object on the car. There is also a rest on the car. So when you look at the motion of B, okay, or this object or this block, so you say that, okay, B is at rest, is it? B is at rest in the car. So that means you think that the net force acting on B is 0. But indeed it's not 0. Even for you, you can experience the force acting on you by the back of the seat, and then you experience a net force to the right. So similar for this object B. So both A and B will experience a net force to the right, but you say that the net force is 0 because you think that B is at rest. So that means the Newton's second law is not valid in this reference frame. So how can we resolve it? So then to resolve it, okay, we still want that, okay, we still want that what you think is correct, because obviously you can see that B is at rest. In the reference frame of the car, we still want the Newton's law of motion is valid in the reference frame of the car. And so that means in the reference frame of a car, B is still at rest, and the net force of B is still 0. But the object A should experience either the force from the back or maybe the friction. So let me draw the friction in this case, because just what I draw is just B is resting on the ground of the car. So let's say there's a friction, and it has a magnitude that's equal to the net force of this object B. So there's a weight, and now there's also an upward normalization. So in this case, these three forces does not balance each other and give you the net force MA equal to the friction. So how can you resolve it to make the net force become 0? So you add a friction. Sorry, you add a inertial force. It has the same magnitude as the net force. That's MA. Now this A is not the acceleration of the object. This A is the acceleration of the reference frame. But in this case, these two A are equal because the object is at rest in the car. So the car and the object are all accelerating at the acceleration A relative to ground or relative to an inertial frame. But indeed, this A should be the acceleration of the inertial frame relative to the inertial frame. Okay. And this is also the inertial force. To talk about the force, you should know that where this force at. So this force at the center of mass of the object. Although we haven't talked about the center of mass, but just keep in mind, you just think that it is the center of the object. So then let's move on. So let me give you some examples. Okay, let me give you some example. So let's say a water cup. which is placed in a car with the car is accelerating to the right at the acceleration A. Now the car is moving in acceleration A. Now let me ask you first, okay? Now the water surface is no longer horizontal. The water surface will be tilted at some angle. So let me ask you whether it is how does the water surface look like, A or B, if the car is accelerating to the right? So you type me your answer in the chat or so what do you think? Is A or B? Yeah, it's A. The water surface looks like this. So there's an angle theta. Then we are going to solve this angle theta. So how to do it? So let's consider a water droplet. Just right on the water surface. So in the frame of the car, you know the car is non-inertial frame because the car is accelerating relative to the ground. So there is also a non-motion acting on the water droplet by the water surface. Because you can consider water droplet is placed on the surface. And then because the car is a non-inertial frame, you should also add a inertial force acting on the all objects. Take a negative ma. The negative means it's opposite to the direction of the acceleration. That's the magnitude ma. This angle is theta. And this angle is also theta. Now in the frame of the car, the water droplet is at rest. Then these three forces will balance each other. Then for the vertical force, you can write as n cosine theta equal mg. For the horizontal force, you can write as n sine theta equal ma. Then you get tangent theta equal to a over g. Okay, then you solve the angle theta. In office, you can see that the larger the acceleration, the larger the tangent theta. And for larger the tangent theta, the angle will be larger. I think so this is one of the case. We can also solve another case. So let's say you are rotating the water, the cup along this axis. Then what you can see, the surface will become like a parabola. Yeah, it is a parabola actually. We can also solve the surface, the equation of the surface, by using symmetry. But in this case, we need to use the integration. I'll just skip it. Then let's have a look at the sum of the past paper that you need to use this trick, or otherwise it will be very complicated for you to solve the question. I'm finding, okay, this one. So the block M is put on a smooth wedge. Now at this moment, the wedge is accelerating to the right at the acceleration A. Find the acceleration of the block relative to the wedge. Now you know relative to the wedge, that means the reference frame is the wedge. And in that case, the wedge is not a inertial frame. Then you need, when you're considering the motion of the block or the free body diagram of the block, you need to add the inertial force. So let's draw the free body diagram. There's no friction, and everything is smooth. So there's a weight, of course, and then the small n is in contact with the wedge, so there is a non-motion. And also there should be also a inertial force opposite to the direction of A with the magnitude that's ma. That's it. And then if you look at the motion of the block relative to the wedge, it should slide downwards along the wedge. So that means you know that the net force is along this direction, along the dotted line direction. Then you don't need to solve the net force along the vertical direction. Then okay, this angle is alpha, then this angle is also alpha. Alternate angle, parallelized, is it? Then this angle is 90 degrees minus alpha. Then the net force of this object will be ma cosine alpha plus mg cosine 90 degrees minus alpha, that means sine alpha. That is m. Net force, you know, that's ma. But I use another a because otherwise you mix up these two these two a. Then very simply, okay, then you can get the answer, that's B. Then let's have a look at another one. Okay, this one. The car is accelerating to the right. You may have a look at the question first. The M1 remains stationary relative to the car. And then I think you may know that the string, this part of the string is not vertical. It should be tilted like this direction. Now to draw the free body diagram of M1 and M2, so let me draw here. So there is a tension. There's a weight. And because I consider the reference frame of the car, because in the reference frame of the car, these two objects are at rest. So we need to add a inertial force, I think, on the M2. And then for M1, there's a tension upwards. It's touching the ground, so there's a non-motion. There's a weight. Also, you need to add the inertial force. And of course, A is at rest, that means there should be also a friction acting on M1 by the object. So after you draw a free body diagram, may you answer me what's your answer for the question 10? Question 10. I think it should not be difficult, is it? You just look at the diagram. Have you solved it? The tension of string. Now to solve the tension of string, of course you look at the Fibonacci diagram of M2, is it? It's much more simpler. Then do you get the answer? Now these three forces bounce each other. You don't know the angle. It doesn't matter. It bounce each other, they add up together to become 0. So you can form a right angle triangle. Then obviously you can solve it by using the Pythagoras theorem. Then I think you will get the answer B. Is it? Then for question 11, if you can solve that the tension is B, then I think you think that the answer will be A, is it? You just get the same form. And then to solve it, okay, the coefficient of friction, that is F, is less or equal to mu n. This question is much easier. So F equal M1A, and then the normal motion is T plus normal motion equal M1G. So that means the normal motion is M1G minus T. And then you get the answer A. Yeah, let me know if you have any question here. If no, let's move on to another one. I'm going to find one similar. But sadly, okay, there's not much question that is quite similar. But let me also send you this question, then you do it after the lesson. Then you try to do it after. No, not this one. Okay, let's see this one. The lift is accelerating upwards. M1, M2 are the string connected to a pulley like this. And then we want to find the tension S. I know the answer, yeah, is A. So what does mean by tension A? Sorry, what does mean by tension S? It's like this. The S is connected to the pulley, and pulley are connected to the string. So there's two tension acting the pulley. So this tension S is just 2T. So that means you're going to solve this tension and this tension. Then we need to consider the reference frame of the lift. Then for the Fibonacci diagram of M2, so there's weight, there's upward tension, and also there is a inertial force M2A. And then for M1, so there's downwards M1G and M1A and also a tension upwards. That's it. No other feedback diagram. And for the pulley system, if M1 is greater than M2, then M1 will have a downwards acceleration. The M2 will accelerate upwards. So they are connected with the same string, so they have the same method of acceleration, but in different directions. Then we try to set two equations. So on the left hand side, so this T is greater than these two forces because the net force is upwards. To solve these two equations, to solve the T, you just try to eliminate the A, and then you can do it by yourself. Maybe I'll give you a few minutes to solve it, and then to see if you can get the answer. Answer should be A. Just a few minutes. 2 minutes should be more than enough. Let's move to the next topic. So the next topic is about the next topic is about there's two names for it. So either someone will call it the equivalent gravitational acceleration, or someone may call it the effective gravitational acceleration. It doesn't matter, it just means the same thing. So this is the you just consider it as the I'll give you the formula first, okay? I'll give you the formula first. So the acceleration of the G prime or the G effective is quite ugly, okay, I think. It's G minus A. So what does mean by G minus A? Now A is the acceleration. So it is quite similar to the inertial force. So when you consider the non-inertial frame, now which has a and then the acceleration of the non-inertial frame relative to the inertial frame is A. So actually it's just the same as this one. Then you can always consider that there is a effective or equivalent gravitational acceleration, which has this form. So what does it mean? So in this case, you just consider that the gravity is tilted by some angle. It's no longer vertical. So just go back to some of these cases. So let's say even for this one, okay? Let's say for this one. Then in this case, you can think it like you consider that the acceleration due to gravity is no longer vertical, and there is a effective gravitational acceleration. That is G minus A. The A is to right. And then, so you add these two together, so you might subtract these two together, you get something like in this direction, is it? Then, okay, so if the gravity is not vertical, then water surface is not vertical also. So the water surface will be perpendicular to your effective G. Then you can use this trick to find the angle theta also. Okay. It seems that you can simplify the case a bit. So maybe let me also give you another question using this trick. And then using this trick, then you can solve it a bit more easier. But it takes a lot of time for you to solve it. So this one. So the car with the constant acceleration is like this, the vertical semicircular smooth track. And the particle is advanced where to the car. Find the maximum height of the particle above the lowest point. Okay. So how can we do it? So we consider the effective G. So effective G has some angle like in this direction. Although you don't know how to find the height, you don't have any concept about energy right now. Okay, just consider you didn't learn about it. Then okay, if the effective G is in this direction, then you know the ball can just go to the same height, is it? Just like if there's no acceleration of the car, the ball will just go to the same height. But let's say that right now the gravity is tilted by some angle, and then you know you can just go to the same height. Yeah, same height. Then you can solve it. Yeah. Then then the question will become an entire mathematics question. You solve it and then you give me your answer. But the answer of course is not A. The answer is not A. And also let me give you some idea of this. How can I say it? Like you try to solve it, okay, and then let me know your answer. Let me know your answer. By just looking at the choices, I know the answer. But let's say if you can solve the answer. Okay. So this is really a very fascinating or exciting trick because you can solve a lot of questions very simply. But for other question, we using this trick, you need to learn about some other concept in other chapters. So then we will leave it later on. Yeah, we finished all the topic about the force. I will give you some more example to look at it. And then we will go on to talk about the moment in the next lesson. Okay. So we left the moment energy. Moment we need to so we use 2 lessons to talk about the moment. 1 lesson to talk about the center mass. 2 lessons to talk about the energy. And then 2 lessons to talk about the momentum. And hope we can finish everything before your commission. Okay, I'll give you this note, and then uh, let's meet next Monday night. Okay, Monday night. Any question? Any question? If no question, then see you lah. Bye bye. Bye bye.